In this video, we want to try and establish this identity by rewriting the two terms on the left with a common denominator and simplifying. So if you recall back to, let's say we had 1/2 plus 1/3. Well, in order to add these, we need a common denominator. And to find a common denominator, often we just take the two denominators and take their product. So our common denominator would be 6. So this would be 3/6 and this would be 2/6. So that idea is what we're going to use to find the common denominator here. So we're going to take the left term and multiply by sine, and the right term and multiply by the cosine in the numerator and denominator. So this whole thing is going to be multiplied by sine of theta divided by the sine of theta. And then this here is all going to be multiplied by the cosine of theta, and then times the cosine of theta on top and bottom. So let's go through and do this product. So in the numerator, when we distribute the sine through, we get sine times the sine is sine squared theta. Sine times the cosine is exactly that, sine of theta times the cosine of theta. All of this is going to be over sine of theta times the cosine of theta. And then plus, so cosine times the cosine is cosine squared theta. And then cosine of theta times negative sine theta is exactly that. Negative sine theta times the cosine of theta. And then again, all of this is divided by sine of theta times the cosine of theta. So now that these have a common denominator, we can just add the terms in the numerator. So when we do that, we're going to have sine squared theta. Sine squared theta. We're going to combine any like terms if possible. So we have sine theta, cosine theta, but we also have its opposite. So those are going to cancel. And then we just have a cosine squared theta. So plus cosine squared theta. And then all of that is divided by the sine of theta times the cosine of theta. Now, if you recall, this in the numerator here, sine of theta plus cosine of theta, is one of our Pythagorean identities. It's actually the main Pythagorean identity, and it's just equal to 1. So we can make the numerator 1. So it's 1 over the sine of theta times the cosine of theta. Now we know that we need to end up with cosecant of theta times the secant of theta. So we can break this single product into a product of two quotients. So this is just going to be 1 over the sine of theta times 1 over the cosine of theta, right? Because if we did this product, 1 times 1 is 1. Sine of theta times cosine of theta is exactly what we get here. And we know that 1 over the sine of theta is the cosecant of theta. And we know that 1 over the cosine of theta is just the secant of theta. And we're taking their product, which is exactly what we wanted to show that it was equal to in our identity.